First, kind of a review. In as much as we've already been using if statements and less than and greater than and stuff like that. So this is saying any decision can be made with only 3 types of comparisons. That seems like a little broad, right? But equals, which really should be equal in all the languages I've used, right? Greater than and less than, or not equals, exclamation mark, right? So you can say if answer not equals 10, right? Then it'll go into the if clause. If you have too many nots in it, it's kind of hard to figure out. I've used this example before, but like if you say, I ain't not going to the store, nobody has any idea what you're meaning. And then if you break it down into, logical English, it means I am not going to the store, which means I am going to the store. But, sometimes people say that colloquially, and it does mean that they're, not going to the store. But anyways, computers don't do things colloquially. It'll do exactly what you tell it. But if you word it in a way like this, right, if not x not equal to 3, that's kind of like, what? Your brain has to do backflips in order to figure out what will happen. Now, in this particular case, it's not too hard, right? Because what does that mean? If you remove the not, it would flip the logic of that. Okay, all that meant is if x is equal to 3. But similarly, if you have this, if not x less than 4, what does that really mean? It means if x is greater than or equal to 4. Right? And that's easier to understand. Our brains like it. The computer doesn't care. But it's easier for us to understand. And if it's easier for us to understand, then we're more likely to write it correctly so that the program will logically behave the way it's supposed to behave. So rather than write, if not x less than 3, write, if x greater than or equal to 3. Notice it's not if x greater than 3. It looks like it ought to be. Looks like the opposite of less than should be greater than. But if you test it with the value of 3, you'll find out it behaves differently. Like what if I had gone and I thought that the opposite of less than was greater than? Well, is 3 less than 3? Tell me if 3 is less than 3. That sounds like a stupid statement, right? And the answer is no, that's false. We would want this one to be true because it's supposed to be the opposite. Is x greater than 3? Is 3 greater than 3? Somebody tell me if 3 is greater than 3 so we can... Right, okay. No, so that's also false, and we wanted those to be opposites. We wanted that one to be true. Oh, sorry guys. I was writing that as though the not statement was there. But anyways. So, to do the opposite of less than, you got to do greater than or equal to in order to count the boundary case, to account for the boundary case where it exactly equals the value. All right. So let's write down the opposites. The opposite of equal is not equal. And if you're taking notes, since I'm not doing it in Python, just start the whole thing, with the triple quotes. The opposite of less than is greater than or equal to. And the opposite of greater than is less than or equal to. So those are your 6 relational comparison operators. One we do not have is that, or whatever variant that you were taught, in pre-college courses. Maybe even some college courses, but in programming those things don't exist. Those don't mean not equal. In this language that means not equal. Or you could use the word not equal, right? Like not x equals y is the same thing as x not equal to y. I wouldn't recommend doing that, though. It makes it harder to understand, in my mind. And I'm going to delete that because I don't recommend it. And since we know how greater than and less than and stuff like that work, I'm not going to talk a lot about it. All right, this is a dual outcome decision, right? Because it does one thing if the customer number is not equal to 1. And ooh, look at that. They're using the greater than, less than, greater than. We don't do that in our programming. I guess it'd be okay for pseudocode, but we should just use not equal. And when I say not, that's the exclamation point. Right, so if customer code not equal to 1, then we give them that discount. Otherwise, we give them another discount. So apparently, if the customer code is equal to 1, they're entitled to a higher discount. And that's a dual outcome, right? Because it's got two ways to go. If it was not a dual outcome, like if their customer code was exactly equal to 1, then when it fell out down here, there wouldn't be another statement. That's just an if rather than an if else. And in this case, I wouldn't want to use not equal. Instead, I'd want to write it where customer code, if customer code equals 1, and I'd want to swap the results, right? That makes sense to me, right? If customer code is equal to something, do something else, do something else. There's times for not equal, like in while loops, you know, loop while, answer not equal, you know, something like that. Common errors, using the wrong operator. I don't quite get what they're saying here, because that looks true to me, and that looks true to me. But you want to use the right one, less than. And missing the boundary of the limit required for a selection. Right, if you're supposed to behave differently, if x is greater than 10 or less than 10, you better decide how it's going to behave if x exactly equals 10. What's it supposed to do? And when I do these temperature ranges, like, you know, below 0 is freezing and above 100 is boiling, I never know what to do exactly at 100 or 0, so I just kind of fluff that. But I ought to be specific. I should say inclusive, right? From 0 to 100 inclusive, there's that math term, right? That means that you better include the 0 and not exclude it, and you better include the 100 and not exclude it. So if we were going to word something like that, if t is between 1 and 100 inclusive, or 0 and 100 inclusive. Inclusive means it has to include 0 and 100. So you have to write it like this. If t greater than 0, but that's not going to work because then it would exclude 0. So t is greater than or equal to 0, and t is less than or equal to 100. That'd be the correct way to write that if statement. And I'm not going to count you off big time on an exam if you don't put the equals, something like that. You'd certainly at least get partial credit. But if I say inclusive, that means that I want you to use the equals as well. If t is out of the range 0 to 100, that kind of implies that 0 and 100 are not part of the range, right? I think so. I don't think I need to put inclusive on that. I think it would confuse me if I saw the word inclusive on that. So I'm just going to word it like that. And to do an out of range, you use or rather than and. If temperature is less than 0 or temperature greater than 100, then do something. So do you do in range? You use and. If you do out of range, use or. And range doesn't mean like a for loop range. It means just you're picking a number and you're seeing if it's between two values. If the question says inclusive, you'll use less than equal to and greater than or equal to. You just have to think through what it's going to do when it's exactly equal or exactly 100 and make sure that it does what you expect. Oh, by the way, if you can't find a document, like you're trying to work on something over the weekend and you can't find the notes or something, I didn't upload the homework document, please text me and I'll get it up there and I'll date the homework assignment based on the date that I was told it wasn't there, right? because that's only fair. Usually things can get solved by a simple text message or email, but I check text a lot more often than I check email. So understanding and logic. Have we talked about and yet? Nope. All right. Here I was using the word and we haven't talked about it yet. Okay. And just means that both sides of the expression have to be true. Like when I wrote this one. Right. If t is greater than 0 and t is less than 100. So I'm going to go ahead and add a statement here. Print, it is in range. Right. It is liquid. Right. It's not boiling, it's not freezing, whatever. Right. But they both have to be true. Both sides of the and, both expressions on either side of the and have to be true. So my silly example is usually, if I am hungry and I have money, I am going out to eat. Not going out to eat if I'm not hungry. Not going out to eat if I don't have any money. Unless I have a credit card. So you would use and to connect those things up. Let's write that down. Both sides must be true. There's a fancier term for sides. Expressions, operands, something like that. So if x and y, both x and y must be true for the expression to evaluate is true. So if money greater than 0 and hunger greater than 0, print, let's go out to eat. Not out to eat. There. I'm not going to go out to eat if I don't have any money or I'm not hungry. How about or? Right? If I am a sophomore or junior, I get the book discount for seniors. Either side has to be true if it's an or. Right? If I'm a sophomore, I get the discount. If I'm a junior, I get the discount. So for or, one side must be true, one or the other. And if both are true, even the better. Although it'd be hard to be both a sophomore and a junior. So or, one side or the other must be true. Both are true, even better. So if x or y, either x or y must be true. And I should be capitalizing true because that's what the Python language does. But I didn't. I'm not going to go back and correct them. I guess I could do a search and replace. If you like doing search and replaces, it's Command H if you're on a Mac. It's Control H if you're on the PC. And I could find the word true and I could replace it with capital T true. And I could do match case if I thought I needed to, and then do replace all, and boom, it did it all. Okay, and here's my silly example about whether for or, right? Not if I have money and I am hungry, but how about if I am sick or tired, I stay home. I have a really generous boss who lets me stay home if I'm either sick or tired, right? So if sick greater than 0 or tired greater than 0, print stay home from work. So in this case, I get to stay home if I'm sick, or I get to stay home if I'm tired. And if I'm both, you know, even better. That's the difference between and or. Those are called logical operators because they work with logic. They work with trues and falses, right? And then there's the third one, not, which I showed you up. Not just reverses the truthiness of something. Not reverses true to false, and vice versa. And that makes sense, right? If I am hungry, I'm going out to eat. If I am not hungry, I'm going to stay home, right? If hunger is greater than 0, print time to eat. If not hunger greater than 0, print no thanks, I'm full. Okay.
Did you mean to say true or false up there?
If reverse is true, to false. It flips them.
Oh.
Flips true and false. How about that? But and in this case doesn't mean logical and. It just means two things. Right. The Colbert Report used to have, he would use the word truthiness. Reverses the truthiness of it. Now we could have reworded this if hunger less than or equal to 0, right? But sometimes a word not makes it clearer. If you think the word not makes the expression clearer, go for it. You don't? Then write it another way. For example, if you do this, hungry equals true, then later on you could do if hungry. Take out the parentheses, that's Java and C++. If hungry, print eat. If not hungry, print no thanks. Right. It's okay to create a variable that has a true or false. It's called a Boolean value. It's also called a flag. That's more a colloquial term, right? It's my flag. If I'm hungry, raise a hungry flag, I'm going to eat. So if a variable is set to true, the flag is set. The flag is raised. If the variable is not set to true. So anyways, we have a flag here. We have a Boolean variable, and it's going to dictate. And we use not in order to activate the negative clause, right? If we were not hungry, no thanks. So a Boolean variable is one that is true or false. It's another type, just like along with int, float, and string. So how would you create a Boolean variable? Or a cold, something like, if I want to determine if I am too cold, say I could write something like this. 2_cold equals, and I'm going to put parentheses around it, but it's not necessary. Temperature lower than 70. I hate going outside when the temperature is lower than 70. And then I could say if 2_cold, print wear a coat. So what happens here? We have an expression that evaluates the true or false, just kind of like it was an if, but we didn't put if in front of it, right? Ignoring the fact that there's an if underneath it. We store the result of this expression, and if temperature is less than 70, a true gets copied over into too cold. So that's the value of the too cold variable. And then if we are too cold, we're going to print wear a jacket. And it would be plausible for you to ask, why didn't you just write if temperature is less than 70? Well, it could be that we want to calculate temperature, being too cold in some other way, or we want to write a function that accepts, and determines whether we're going to print a jacket or whatever. The idea of a flag being based on an expression is not a bad idea. What if we're going to check this variable multiple times, but each time a comparison is done, it takes the computer longer to do? And yeah, sure, it only takes, a very short amount of time, but if you're trying to write code that runs very often and needs to be very optimized for speed, you would only want to do that comparison once, and then you could store it in a variable and then make all your decisions based on that variable, and it would happen a lot faster, especially if this was a more complicated expression than just temp less than 70. Right? If you want to print whether something is a gas or not, you have to actually, if you're taking physics, know several things. You have to know the temperature, You have to know the pressure. You have to know the gas temperature curve. I forget the phase diagram for it. There's a lot of information that goes into determining whether something is a gas or not. And you certainly have to know the specific temperature and the pressure. Now, so this could be a complicated expression. You could calculate it here, and then underneath it, you just say if gaseous, right? Makes the code easier to understand so that even if you don't understand that expression, you understand what it's doing underneath it. So, and logic. And logic, it says it requires a decision, a nested decision, a cascading if statement. Sort of. Right? How about this? If sick greater than 0, colon, tab, if tired greater than 0, colon, print, parentheses, wait. That's an or logic. Erase, abort. Okay. If hunger greater than 0, if I am hungry, tab, if money greater than 0, I have some money, print, go out to eat. So, nested if statements can be replaced with and. Usually. So, if hunger greater than 0 and money greater than 0, print, go out to eat. Logically, these are the exact same thing. Is there a reason why you would write one over the other? To my eyes, this is clear. If you disagree, go ahead and write it as a nested if. There are times when you would pretty much be forced to use and because you would wind up with all sorts of nested statements and sequential statements and stuff like that. So how about or? Or does not replace nested statements. Or replaces single sequential comparisons that give you the same result. And I don't know how to write that in terms of a shorter English sentence. Hopefully the PowerPoint will show you. But something like this. If tired, colon, print, stay home, end quote, and don't use an else. If sick, colon, print, parentheses, stay home, right? So I get to stay home whether I am sick or tired. So I could replace that with an or. So sequential if statements that produce the same result can be replaced with or. Not if they don't produce the same result. And so if sick, let me push this text up, make it easier for y'all to read. If sick or tired, colon, print, stay home. Does that make sense? And both of them have to be true, because if the first one wasn't true, we wouldn't even get to the second if. And if the second if wasn't true, we wouldn't get to print, go out to eat. And or means that, well, if that if is that, well, yeah, we're going to do that. And if sick, we're going to do the same thing. So sequential if statements that produce the same result can be replaced with or logic. Nested if statements can be replaced with and logic. And it can get more complicated than that. How about if we have some rules about whether you earn a 100% discount? You get a 50% discount only if you're a recent graduate and you have a job. That's kind of jerky for us to only give a discount if you have a job. Maybe we're applying for a loan or something. I don't know. So something like this. If recent underscore grad, if we're a recent grad, colon, if employed, colon, print quote, congrats, discount, in parentheses, else colon, print, must be employed, else colon, print, must be recent grad. We could clean up that logic by using and here, right? We have nested ifs. Now it looks like it's more complicated because it has 3 cases, right? It's got double elses. But let's give it a shot anyways. If recent grad and employed, colon, print, parentheses, quote, congrats, discount. Else, colon, we better tell them why not. Print, must be employed and be a recent grad. End quote, in parentheses, like that. So we cleaned up the logic a little bit. This is a lot easier for me to understand. The other one works. There's nothing wrong with the logic, but it's simpler, right? We took out the nested stuff, and there's only 2 outcomes. It's a dual outcome rather than throwing in a whole bunch of elses and giving ourselves 3 outcomes. Really, if you have 2 variables, recent grad and employed, you wind up with 4 states, right? Because if you have grad and employed, you could be a graduate but not employed. You could be not a grad, but you could be employed. You could be a graduate and employed, or you could be neither, right? So 2 variables gives you 4 possible states. 3 variables gives you 8 possible states. I shouldn't be saying variables, Boolean values, right? 4 Boolean values gives you 16 possible states. Now, how am I rattling those off? It's just 2 to the power of. If you only have 1 variable, right? I'm hungry. It only has 2 possible states, yes and no. And yeah, we could try to come up with what's known as fuzzy logic, where I'm partially hungry. We're not talking about fuzzy logic. We're just talking about hard logic. I could either be a graduate or not a graduate. So if we only have 1 variable, we have 2 options, 1 to the power of 2. If we have 2 variables, we have 4 options, 2 to the power of 2. Seems like I've got that wrong. 2 to the power of 1, 2 to the power of 2. And if you have 3 variables, it's 2 to the power of 3, 8 different options. Just like binary. If you have 3 bits, you have 8 different possible numbers that those 3 bits can create. If you have 4 variables, 2 to the power of 4, which is 16. I just happen to know that because I keep doubling it each time. 2, 4, 1, 2, 4, 8, 16, 32, 64, and so on. But what we have decided is that this is the only case where they get the discount. In all other cases, they don't get a discount. And so they both had to be true. Otherwise, we didn't care. So that's why we used an and. So we can create what's known as a truth table. I'm going to revise these true-false things because I wish I'd done them in a different order. I'm going to make that an F and make that an F and make that an F and make that a true and make that a true and make that an F and make that a true and true. This is the only time that the result is true. Right? Otherwise, it's always false. So and means that both variables have to be true. Both sides of the expression have to be true. This is what's known as a truth table. It could be rewritten by substituting 0 for F and 1 for T. That's a binary truth table. How about sick or tired? Sick, tired, and the OR result. Well, if I'm not sick and I'm not tired, I'm going to stay home. So that result is false. If I'm not sick but I am tired, I get to stay home. Woo. If I'm sick but not tired, I get to stay home. And if I'm both sick and I'm tired, even better. So the only time OR is true is if both sides of the expression are true. The only time, and. The only time and is true if both sides of the expression are true. The only time OR is false is when both sides are false. Because either one could be true, knocking it over to true. Then it's actually taking it further than you wanted to know. You already know the meaning of and, right? You already know the meaning of or. We're just kind of expressing it in computer sciencey terms. Okay, we're kind of boiling it down. I want you to know the term truth table. This is a truth table. And the truth table for not looks like this, right? It started off false, it becomes true. Or it starts off true and it becomes false, right? So X and a not X. If I'm not cold, right? If I'm cold or if I'm not cold. If I'm hungry or I'm not hungry. Is this making sense, guys? A couple people meet my eyes and nod your heads.
I didn't understand when you said and on the bottom that all is true on the other side of the end.
Right. If we're looking at this, what is the only time we actually get a true? And that's if both sides of the expression are true. I am a grad and I am employed.
Oh, so shouldn't and be down there between those?
Well, yeah, we're pretending that and is all the way down between those. I put the word and here, but if I wanted to, I could revise this to like F and, right? And I could do the same down here. I could stick in ors.
Okay, now, the only time that you got true on both sides of and down there, it's on the bottom. So wouldn't that make F and F undergrad and employee true?
Nope, because if you're not a grad and you're not employed, then you don't get the discount. If you're not hungry and you don't have any money. So the only time we get a true result is if both things are true, not if both things are false. It's not that they match, it's that they're both set to true. I am sick and tired. I am hungry and I have money. That's the only time I get to go out to eat.
Well, number one is definitely true. I mean, for me,
Pardon me?
I haven't graduated. I have graduated, false, and I am employed, false.
Right, and so you don't get the discount. Yeah, that makes sense?
Yes.
Yeah, okay. And an or, I can vote if I'm 18. Wait, I can join the, no. Trying to think of an or besides my sick or tired example. Well, we get a discount. We change the rules. We get a discount if we are employed or we are a recent grad. You get the credit card. And so the only time you don't get the credit card is if you are neither employed or recent grad. If you have a credit card, great, you get it. If you are a recent grad, great, you get it. If you're both a recent grad and a credit card, hey, maybe you even get a better interest rate or something like that. So this is just a slide showing that if if we have made any calls and our call minutes are over the minutes, then we set them for premium, right? It's kind of weird. That seems like more like an or. You've made too many calls or your minutes have exceeded your max minutes, but whatever. This rule is that if you've made too many calls and you've used up all your minutes, then we're going to charge them a premium. And we could replace this, since this is a nested and, with the and keyword. If calls made greater than calls and call minutes greater than minutes, then charge them the premium. So when nesting decisions, either selection can come first, but you can improve the performance. Now this is kind of technical wonky. This is called short circuiting. What if I am in a high school and I want to create a special program that only lets people in who are greater than 17 and whose parents are Hispanic? And let's say that we live in a town with a lot of Hispanic people. So that's the logic we're going to set up. If you are over 17 and you are Hispanic, then you go to the special program. Hispanic. All right. All righty. Now there's two ways we could write this, and one way is more efficient than the other based on which one is true more often. Now this is high school, so very few people are over 17. Let's say that very few people are greater than 17 and a lot are Hispanic. Then we can write an efficient, the one that will run more quickly. If we do this, well, I'm going to write it two ways, and we're going to figure out which one's more efficiently. If Hispanic and age is greater than, okay, let's just do if Hispanic equals true, because that makes it clearer, but you could leave that part off, honestly. If Hispanic is equal to true and age is greater than 17, alrighty. Or you could write it the reverse. If age is greater than 17 and Hispanic is equal to true. Alright, to figure out which one of these is more efficient, we have something that is being triggered in here. Do something. And we have the same thing being triggered based on this case. And the logic is identical, right? This do something will happen only when we are Hispanic and our age is greater than 17. But we are very, very, very rarely going to find people who are over 17 in our high school. So this check gets done first, and if this is false, the computer doesn't even do this check. So we get to skip this check, or the computer skips this step. Why? Because they both have to be true. And if one of them is not true, then we're not going to do or something. And so, since very few people are greater than 17, it gets to skip this step an awful lot. What if the opposite was true? What if like only 1 out of 1,000 people were Hispanic, but a lot of people were greater than 17? Well, if hardly anybody is Hispanic, then this check will usually turn out to be false, and it won't even do that check. Which is good, because anytime the computer can skip code, it's good. So I'm going to rewrite this as a nested if, and hopefully that makes it even clearer. If age is greater than 17, if Hispanic equals true, do something. You see what I mean? If age is not greater than 17, it won't even do that check. And every check does take a finite amount of time. And if we're really concerned about performance, we're writing graphics drivers for Fortnite or software that gets put in a car or, you know, a jetliner or something like that. And then you want your software to be as efficient as possible. For the kind of stuff we're doing, where it doesn't matter if it takes half a second to run as opposed to, you know, a quarter of a second to run, it doesn't matter so much. But we're going to give ourselves a general rule. Put the case that is true less often before the other one when using AND for efficiency. And the technical term for that is short circuiting. Sounds bad. Don't know who made that term up. But we get to short circuit it. We get to skip it. If 8 is not greater than 17, we're skipping that stuff. We're short circuiting. I don't know why they came up with that term. I'm not sure if the book uses that term. But that's what that slide means. I'm going to slip back over to that slide in a minute. So in an AND decision, put the question that is first less likely to be true. Now the opposite is for ORs. Right. Say this program lets you in if you're Hispanic or you're over 17. Right? So if Hispanic equals true or age is greater than 17, then print do something. Or just do something, whatever. If Hispanic is true, we don't even need to do the second half of the check, right? Because only one side has to be true. So we get to skip this check if this is true. And so we want the check that is true most often. So that we get to skip this step the most often. So for OR statements, you want to put the one that is true more often than the other. Put the case that is more often true before the other when using OR for efficiency. Now I can't illustrate that with a nested or whatever, or with, you know, with sequential whatever. Yeah, they are calling it short circuiting. Short circuiting are when part of the AND or the OR expression is being skipped. That gets skipped, it's been short circuited. If that gets skipped, it's been short circuited. So again, this is another example of short circuiting. Now this mentions truth tables. Truth tables are those true-false things that I set up. On the truth table, the only one that goes to AND is when both sides of it are true. In a truth table, the only thing that is false if you're using OR is when neither side is true. Otherwise, they're all true. Okay, their example's pretty similar. If I want to go to the movie and I have enough money, then I will go to the movie. Expressions should not be trivial. All trivial means is it's something that's always going to be true. I can't ever really think of when you would write a trivial expression, right? except if we do while true, which I think I've shown you before. But what would be another version of while true, right? If age equals age is always going to be equal to age. So this is a trivial expression. You better have a real good reason. The only time I see trivial expressions as being useful is if you want to do a while loop. You want something to repeat infinitely until a certain condition happens and you can return or break. This is the only trivial expression I can even imagine using. Trivial expressions are always true, so why have them? Or they're always false, right? Either way. They always get the same result no matter what. Or do something if one or the other condition is true. Are you free for dinner Friday or Saturday? Now, we couldn't express it like that in a computer. We'd have to express it something like this. If free day equals Friday, or free day equals Saturday, right? Here's what we cannot do. I wish we could. If free day equals Friday or Saturday, right? It looks good, but that's not computerese. That's not programming. Wish it was, but it's not. Can't do that. Both things on either side of the or have to be a complete expression or true-false value, right? That is a complete expression, and that is a complete expression. Can't just write if free day equals Friday or Saturday, which is how they worded it in their pseudocode up here. So for or, you can ask you the question first, but if the first question is true, there's no reason to ask the question. So it's better to ask the question that is more likely to be true, which eliminates the second clause. That's that short circuiting that I mentioned. So common errors. You have to make sure the Boolean expression is complete, meaning you haven't left anything out. Not if age equals 17 or 18. Has to be if age equals 17 or age equals 18. Make sure that selections are structured. Don't really know what that means. Guess it just means good logic. Make sure to use or when they are required. Make sure the expression is not trivial. All right, we're going to cook up some homework on this. I haven't even made y'all type in anything. You may have been typing in something. If you haven't typed in a single thing because I didn't open up Python, maybe I should have opened Python. But you've been writing it, yeah. And that's cool. Just create a note in Python or something called Lecture N or whatever lecture we're on and upload it saying you were here, if you would not mind. And when I say if you do not mind, I highly recommend it. Okay, so our homework. Ask the user their age. Ask them their years of employment. And now we're just going to have a whole series of conditions. If their age is 17 or 18, now remember, You can't write if age equals 17 or 18. You have to write if age equals 17 or age equals 18. Then print. What are we going to do if you can say 17 or 18? I'm going to revise that. If their age is greater than 17 and years of employment is greater than 2, then print you get free checking. If their age is less than 17 or their years of employment equals 0, print enroll in the training program. That's kind of not fair. Maybe you've worked for 10 years as as an electrician, even though you're only 17 years old, but whatever. Oh gosh, we got to do more than that. I'm going to cheat. Now, if you ever take a logic class, it gets really, really hairy. All right. So ask the user how many calls they have made. Ask the user how many minutes they have talked. If calls is greater than 100 or minutes is greater than 1,000, then print upgrade to the higher plan. If calls less than or equal to 100, and minutes is less than or equal to 1,000, we're going to say stick with the current plan. And then lastly, if calls equal 0, let's print. You might as well cancel your plan. All right, I think that's enough. That makes sense? I think we already have a Dropbox in. Let me go look. Could be wrong. Yeah, we do. All right. If you took any notes, upload it. If you didn't, create a document with your name and upload it. Just say you were here or that you watched the video. If you watch the video, what I would prefer you to do is go to Content, go to Class Information, and fill out the video, the lecture video form, just proving that you watched it by saying a couple things you learned from the lecture. Now, don't put I already knew all this, right? Because, yeah, arguably you may already have known all this, but instead, list some of the things we were talking about. Doesn't have to be a big, just list like, 2-3 sentences, things we talked about.
Can I screen print my notes?
Yeah, you can upload them like that if you want. Sure. That's cool. All right. Any questions over that? Hope this has made sense. Ands and ors are real important for understanding programming. About as important as loops are. Once you have the concept of loops and functions and or, you're like 75% of the way. I'll revise it. If you understand and, or, loops, functions, and lists, then you're 75% of the way there to knowing everything you need to know about programming. And that's an exaggeration, but those are the primary, those are the big concepts. Those are the things that everything else is built on. All right, I'm going to stop this.